Hello and welcome to our Covestro home office talk, all live as always. We do a live interview today and answer your questions, which you could send us right away from your desktop or mobile device. In our virtual studio, we will touch a highly interesting topic today, joining forces for artificial intelligence in the chemical industry. Talking about AI, you might ask yourself if the moderator today is a deepfake. Well, it's not. I'm real, and so are my guests today. Yves-Gorat Stommel, Head of Cognitive Solutions at Evonik Digital. Hi, Yves.
Hey, how are you doing, Peter?
Hi. And Nils Janus, Head of Advanced Analytics at Covestro. Hi, Nils. Yves, hello to Essen, to your home office, I guess, right?
Yes, correct.
You are an AI expert and an author too. So in your spare time, you're writing science fiction novels. So is AI also a topic for your storylines there?
I just wrote a science fiction novel, it's correct. It's not published yet. I had 4 or 5 fantasy novels, but the latest one that I wrote, actually, yes, it does feature AI. I am actually already, before I started this job about 1.5 years ago. It's a long process writing, right? So it's a hobby really, but it does. So next to bionics, genomics, it also has AI. It has to, right, if it's about the future.
Super interesting for another talk, maybe. Nils, hello to Leverkusen home office. I've heard that you are a gaming expert in your spare time, so AI helps a lot there too, I guess. What would you say? Is life without AI more boring in the end?
I think you might have frozen up, actually, Petra. Live session. That's what happens.
Sometimes it's like this. We are really sorry, but let's dive into it now and let's get it started, the topic. So we will come back to that later. So it's a message to your home office, dear people outside. So please remember to post us your questions on AI in chemical industry right here in the chat below, and we will answer them, of course. So as soon as we get them, and of course in the course of our conversation. So artificial intelligence and chemical industry, to get us all on the same page. So what is artificial intelligence? What is the definition?
We always say it's kind of a machine that mimics human mental processes. So basically takes things that people typically do and transfers it in silico, as you say, in the computer. That's kind of the short definition of it, right? Typically, it's very narrow today, so it only does very specific tasks like maybe image recognition or voice recognition or correlations. It's not what we typically see as human intelligence yet. That kind of spans a much broader sphere. But nevertheless, we often call it I would say, a general purpose technology. So really being useful for many different applications.
And we might have also some participants today from other industries than chemical. So I think a short definition of the chemical industry also makes absolutely sense. How do we define chemical industry?
Sure. So probably not a big surprise that the chemical industry is composed of the companies that make chemicals, obviously. To provide maybe some structure, it has 4 main blocks, I would say. You have the basic chemicals. So these are things like petrochemicals, for example, or polymers. Then you have the specialty chemicals, for example, coatings or catalysts. Life sciences, those are probably more known to most people. So we have things like pharmaceuticals, vitamins, pesticides. And finally, we have the smallest group, probably by volume at least, which is the consumer products part. And there we have things like, let's say, household products like cleaning agents, detergents, or cosmetics. So overall, it's actually a pretty large industry. So it has a turnover, at least in 2019, I looked it up, of about 3,900 billion US dollars. So it's almost $4 trillion. And just actually in Europe, it has about 3 million jobs connected to the chemical industry. So it's quite significant.
So how do these fit together, these two let's say, parts AI in chemical industry. Is what is the relevance really for chemical if we see production and plants and everything?
So they fit together perfectly, I would say. As I said before, it's a general purpose technology, right? So it really can be used for anything that basically works with data. So no matter if you're looking here at, let's say, marketing and sales, procurement, production, R&D, application-related technology, finance, controlling, you name it. Anything that uses data can theoretically benefit from artificial intelligence, right? So again, this general purpose technology kind of definition there. Typically what we try or what we say is to make it more tangible is that AI can be used to really improve or even reinvent processes, products, or business models. So the whole basically value chain there. And Nils and myself, once he's back, we actually brought a few examples that we could share if that's interesting to you in the audience.
Mm-hmm. Definitely. Yeah, so Nils is facing some technical problems actually, so this is why he's struggling to join back the live conversation. So as you see out there, so this is really all live and we don't record and we don't fake. So unfortunately, he might be taking some time to get back due to really connection reasons. So, but Yves, let's go on. So the topic is absolutely relevant, and I'm pretty sure that our viewers outside there will have some good questions to you, Yves, and later on to Nils, of course. You could write it, you could type them into the chat, and we will answer them later on. So please think of that, and happy to receive your questions. So Yves, you've brought a pretty interesting use case to us for processes to show what's really into it for processes. It's called SciTAI, and we can see it also in a video animation right here. So what is this technology about?
Yeah, so like I said, it's for a process, specifically in this case for an R&D process for one of our business lines, high performance polymers. So that R&D team, they are developing new compounds. A compound is a polymer with additional ingredients, for example, pigments, and you make this compound. And they've been doing this for many, many years, for decades actually. So they have a lot of information in documents, databases, texts, files. And what we did now is that this is all put together in a so-called knowledge graph, as you can see right here on the screen. And that allows now really to do multiple things. Number one, because everything is interconnected, all that information is interconnected, you can very quickly find what you need, recognize patterns, understand where you might have to go. And this may be even more interesting, you can actually define or find new materials based on that network. So let's think, for example, about a customer that you have, and the customer says, well, you know, for a certain application, be it an automotive or whatever, I need a certain compound, a certain polymer with certain application parameters. So for example, density, viscosity, color, whatever it may be. And then you can plug those application values into your knowledge graph. And that graph will then actually provide you with a potential good recipe for a new product that would fit to those application parameters for your customer. Then, of course, you go to the lab and you test it. The other way around, what you could also do is you can put in a specific recipe, and then the knowledge graph would kind of tell you what your application parameters might be. So you really kind of turn it upside down, right? You don't do so much in the lab anymore. You really do first in silico, as I said before. So you take this thinking process into your computer, you define a new product, and then you test it. And we just started using it actually with the prediction part to it. And we now already see probably a reduction of at least 20% in our R&D times, which is really significant.
Yeah, super interesting example. How long have you been working with it right now?
So these things are really cutting edge. So it's not something that we, you know, throw out there in a matter of weeks. We started working on this about, I think, 2 years ago. And about half a year ago, we really had a good first version to also do prediction. So we did it in multiple steps. And we're now testing it. And we'll also then, of course, see if we can maybe roll it out broader in the company, make it available to others. Nils, you're back.
Hey! All right. Yes, I am. This is
wonderful.
This is best proof for us being really live.
Yeah, welcome back. So yeah, this is what I just mentioned. So it's all live, and now we can really go on. So we already dive deeply into the topic, of course. So, but happy to have you back, and to our viewers outside there. So please post us your questions in the chat, and it's really interesting topics here we are discussing. And Nils, as you are right back now, so we've defined the meaning of artificial intelligence and chemical industry, and how both can really join and get the full potential out of it if we really see both topics together. And Yves just presented the first use case for processes to show to us called SciTAI. So we just dive deeply into that a little bit. And now I know we have a really interesting second use case for infrastructure and processes to use AI in a DSD plant of Covestro in Dormagen. And we have also a short video showing this to us. So could you please explain us what we see there, or what you expect from this pilot project?
Definitely, we'll gladly do so, Petra. So the DSD plant is our largest and most complex polyester production site that we have globally within Covestro. And as with many chemical production processes, there are highly complex and highly non-linear in nature, meaning very small changes to the process can cause very large variations in the reactions. In this specific instance, the challenge was to identify why we have wide variations in the distillation times. And this is a challenge that has been taken on before. What we have now done together with Sabine Pedel that you can see here is we did train a model based on all the available data without any prior knowledge. So the model, the AI, actually learned how this DSD plant works, where we could then ask very specific questions about why reaction times for certain batches, for certain products, for certain reactors do vary. What this helped us and the colleagues to do was, rather than formulating many hypotheses beforehand that would then be answered and modeled individually, we could ask all those questions and all those hypotheses to the model directly. And yes, the colleagues had a very strong hunch about what influences and causes these variations in distillation times. And what we jointly found out that in very specific situations, this hypothesis has proven to be correct. In many other instances, though, there were a lot of different influencing factors that were never taken into account.
Right. Yeah, very interesting use case. And we just published also this video online today about this pilot project, followed by many other examples in the next months. So yeah, let's keep an eye on that. And Nils, there is also another use case for products at Covestro. It's called Slab Expert. Could you explain to us, please?
I will gladly do so. I think we've heard about a project called SciTAI, a solution from Evonik. And what Slab Expert is, and this is now a solution that we deploy at the customer's site that our colleagues in Pittsburgh in North America developed. It is used in the flex foam production area, and it allows our customers to predict properties of the finished material based on the ingredients they have available, based on the additives they have available, for example, additives that also come from Evonik, to then shorten the amount of iterations required for them to produce a perfect result. Now that this challenge has been solved one way, it automatically also answers the question in the opposite direction, meaning if one of our customers has the question of, if I want to produce slab stock with the following properties, which type of ingredients, in which type of composition, from which vendors do I need in order to be able to produce just that? And this is just another great example of how we can bring not only the chemical, but also the chemical process engineering expertise from Covestro directly through our customers, because the combined knowledge of decades of research and development our colleagues in North America have taken, put that into a model that is now being made available to our customers.
Right. So this is a good, good addition to what we heard before from Yves. Thanks, Nils. I know you've brought another fourth example, a last one, which is really interesting to show how AI is able, to accelerate chemical industry. So, if this is a last use case on precision livestock farming, a very also important part of chemical industry. What is it, please?
Yeah, so it's actually interesting what Nils just said, basically going to the customer, or even maybe the customer's customer. And this is kind of behind this idea too. So it's not as much about just selling a material anymore, which is where the chemical industry really is coming from. Like we sell a material, but actually looking more at the ecosystem, at the overall ecosystem of in this case, precision livestock farming. So meaning, for example, chickens farming or chickens rearing. So we have a business line in Evonik called Animal Nutrition, and they produce nutritional building blocks for livestock. So, for example, amino acids. These are being added to the feed to make that nutrition for the animals more balanced, getting high performance out of the animals, cost savings, but also environmental savings. And this precision livestock farming service has really moved past just servicing our customers with those amino acids, but actually adding additional tools and building blocks. So if we just start with the animal nutrition first, next to just the material, what we're now also supplying are tools, analysis tools and softwares that basically allow the farmer to analyze their own feedstock, see how much they would need from our amino acids, mix it in, apply it in the right way to the animals. So it gives them kind of an application suite directly. Although we're obviously not a software company, so we kind of have a forward integration to the ecosystem there. A second building block would be animal health. So also again, a software plus analytics solution that is given to the farmers, where they can now, based on fecal matter typically from the farms, they can early detect or have an early detection system to see if there's any animal health issues that they would have to act upon before actually there's an outbreak or there's a certain problem. And a third one, which is called farm data management, is where we take together, for example, those data streams that I just mentioned, but also, let's say, pictures from your chickens, weights, water quality, temperature in the farm, and all those things, you put them together into this AI system. And what it does, it gives you an indication of your performance in your farm, and it also gives you a prediction. So it tells you where most likely this specific flock is going to end up in terms of weights, distribution, and so forth. And this is really important because on the one hand, you can again do an early intervention and change some parameters in your rearing, and this would lead, for example, to a more uniform stock or flock, which is really important for the supply chain overall, but also the planability really increases. You know what you're probably going to have in 10, 20, or 30 days. Again, important for supply chain, but also for just planning your own operations. So you see really that based on these, I would say, data-driven tools and analytics like AI, you're able to now to really do a more integrated offering for your customers.
Yves and Nils, we have really good questions already from our viewers outside there, really relating to your cases here. And it would be great if we could come to the first question now, if possible. So this is by Mohammed. So where are we on the use of AI to develop new materials with specific characteristics? Yeah, where are we? What would you say?
Sorry, I didn't.
You want to take that?
Okay, sorry, I didn't. Yeah, it doesn't. Actually, it's a good topic because we talked about this, Nils, right, quite a few times. So the question is really: is a new material something where you do something similar, right? Let's say you already have coatings and you want to have a little bit different coating, or is this viewer really asking about completely new materials, right? Completely out of what we typically have thought about. That might still be more complicated because typically AI learns on data, right? So you have to have some historical data that you learn on that you can then use to extrapolate that space. You can go outside of that training space, as they call it, but it's more complicated. But specifically, I mean, SciTAI was one example that you can generate new ideas for new materials. Yes, that's already used today, actually, and it really makes a big impact. And maybe, I mean, in Nils deep fold, I think you're also pretty close to that, so that may be another good example for that.
Exactly. I mean, some of the viewers might have heard of a deep fold, which is a model that has been trained by Google colleagues that now solve protein folding, or the question on how a given protein is going to fold in three-dimensional space, and thus allows researchers to shorten the time to understand this behavior of a protein much, much quicker. Now, we as Covestro, obviously, we don't build proteins, we build polymers. Yet, some of the knowledge is transferable, will be transferable, and what we at Covestro usually do is we combine first principle type models, so ab initio simulation, Monte Carlo simulations that have been established for decades in the field, and now combine them with the data-driven approach. Because we feel that these hybrid modeling techniques that basically take the best of both worlds allow us to move even faster and do even more than if we would only focus on one of the two components.
And maybe add to that, because that's a really good point. I just mentioned that for AI, you typically work on available data, historical data. And that's a limitation that first principles models, ab initio modeling doesn't have, right? You can really extrapolate with that. So, but often you don't have enough, or you cannot simulate everything, right? Because it would be too intensive computational wise. So again, I think also that hybrid models certainly have the future, right? Taking the best of both worlds.
A relating question to that from Yasir. So you already elaborated what currently is going on in AI for its business in chemical industry, but how safe is that? This is interesting.
I mean, safety has a lot of different facets to be considered. Something that is widely debated also in the public is around ethical AI, where it can be considered, is it safe to use the results of an AI or a machine learning model, for example, to predict trials? We as Covestro and in the chemical industry generally obviously have a very, very strong safety conscious, because we operate with hazardous materials, with hazardous materials, and thus have very, very, very high focus on safety. We do differentiate in the usage between whether it is a purely business risk that we take by leveraging AI. For example, when we predict likelihoods of interested potential customers in our products, how likely it is that they will actually become buying customers. Or when we predict what the next type of material our customers really want. This is a pure business risk that has no impact on the health and safety and well-being of Covestro employees or anybody around. Now in the plants, it obviously becomes a different question. When we think of the vision of a self-optimizing, self-driving chemical plant, we are not there yet. and we will likely not be there in 2021, that an AI may autonomously makes decisions over our chemical production processes.
Yeah, so we often, for these kind of things, we have the so-called in-the-loop system, right? So you have the system, AI system might make predictions, and they might be very valuable, but there's still a human who has to then say, yes, I accept these, or I'm going to transfer these, for example, into your DCS, your control system. But it's a very important question. You always think about what are potential ways this could go wrong. I think the good thing about the chemical industry, though, Nils, is that often we don't have a lot of data where we would have issues with bias. Right? Bias is a very big topic in AI, that you kind of build in, I would say, biases of people into your algorithms. But as we're typically talking about technical processes, this is not that big of a, I would say, at least legal issue.
Of course, this is different from driving or mobility, of course. Yeah.
Exactly.
So I would say let's take a third question before we go on to our last block. Really important. So how is AI in the chemical industry related to linear programming or design of experiments? This is Jeffrey who is sending this question.
Yes, you want to go ahead first?
Go first, gladly.
Yeah, okay. No problem. So design of experiments is a very good, actually, I would say, keyword there. So design of experiments has been used for many, many decades again. What you see now coming up is actually smart DOE, as it's often called. So it takes certain, I would say, artificial intelligence approaches and applies it to design of experiments to make it even more powerful, typically in this case with Bayesian optimization. It is highly important because, again, you will never get away, for example, from completely not doing any experiments, not doing any lab work. You always have to double check. So you still need to do that, but of course, minimize. So I cannot read the whole question here. How is AI in the chemical related to linear programming or design of experiments? So it is directly related. It uses it on a daily basis, be it for R&D, but also for production, right? So if you don't want to do production trials, that's also very important.
Wonderful.
So, if you allow me to add one thing, because I second what you just mentioned. On the other hand, why this is exciting for me as a mathematician and also for me as a data scientist is using Bayesian optimization or Gaussian processes allows us to get away with fewer and fewer and fewer data points. And especially in the chemical industry, where every experiment that you conduct costs a lot of money, including physical testing and everything, if you can reduce the number of trials we need to run before we have a new material with the wanted properties, it impacts our speed, it impacts our cost, and it impacts our customer satisfaction tremendously.
Right. Yeah, great questions here. Thank you so much. So think of really sending us more. There are more already, but go on and we will take them all. But first of all, we would like to come to a very important topic, which we would like to tackle today. This is collaboration in AI. So why should that be really necessary? We see two big players here in chemical industry, Evonik and Covestro. Both are doing first steps and really good results already in AI. So why should that be? And we've done a good poll here, so we can take a look maybe at our poll on social media. We did a poll on Twitter and LinkedIn in the recent days. And what you see here, we asked you, what is the most urgent need to advance the use of AI in the chemical industry? Is it experts? Is it technology? Or is it code? And you said there, you said on Twitter, you said cooperation clearly with 56%. And on LinkedIn, you answered it's both technology and cooperation with 41% of your answers. So how would you comment, Yves and Nils?
I mean, I'm happy to see these results because, and I hope that I speak for the both of us, that they strongly reflect our perception of what is really going to drive AI adoption in the chemical industry. The cooperative or collaborative part is not only within the company, but also between companies. Tremendously important, because the chemical industry, as a very traditional industry, is in the adoption of artificial intelligence, came later to the game than other industries. Yet at the same time, we want to achieve very similar things with artificial intelligence. We are faced with very similar challenges, and we feel that if we can, obviously only what is legally allowed, to share and collaborate, we will make the whole industry better, faster, and especially now in a time where circularity and sustainability have become the most important topics for our industry. If we can jointly if we jointly utilize resources better and spend less resources, then this is a great benefit not only for the individual companies and the industry, but also for the planet.
Absolutely. So we have some good examples, right, Yves?
Yeah, I think the best example actually was the Chemalytics conference that Covestro had. I think you have a video on that, but Nils probably would have to comment on that.
We see it now in the background, right? This is the Chemalytics conference. Yeah, would you like to comment?
Gladly. So when we set out on this endeavor to understand what AI can do for the chemical industry better in 2018, we quickly came to the conclusion that obviously it's a hype topic. Obviously, there are a lot of conferences out there on general machine learning, artificial intelligence, and whatnot. Yet we didn't found any specific format for the chemical industry. We were looking for something like that for a while, and after we didn't find anything, we asked our colleagues from Evonik, we asked our colleagues from Bayer to say, well, should we just host something, a format of a conference that focuses on data science, artificial intelligence, specifically for the chemical industry? Not only did we have great talks and great knowledge sharing already, but we also developed a stronger network around the topic. We invited students of global universities to join us there to see that in addition to the Alphabets and the Ubers and the Facebooks of this world, the chemical industry is a really interesting industry for machine learners and data scientists to work in, because there is not a single type of data that we as the chemical industry are not going to have somewhere. That is what inspired us to do this. That was a very, very good start that we're looking to repeat in 2021 now. Yet Yves-Gorat and his colleagues from Evonik also went a step further to stimulate even more collaboration.
How does that look like, Yves? What is it about?
I mean, it was really building on what we saw at the Chemalytics, right? Because it was a really good starting point to get people together, as you said, Nils, to start talking about this, bringing chemistry and AI together. But even those two, if you look at the intersection of chemistry, of chemical industry and AI, it's still a huge intersection, right? And we are not data science companies, we're chemical companies. So we will never be a Google or Amazon, so we only have limited resources. So based on Chemalytics, we said, okay, still so many things to discuss. Would it make sense to maybe take a few deep dive topics, focus topics, and delve a little bit deeper to really, get to the technical nitty-gritty? And that's what we started doing. So we chose a first topic for that, which was materials discovery. We actually talked about materials discovery already today with SciTAI, for example. So what it really means is that you, in the area of R&D and application-related technology, you try to explore and exploit the chemical space, be it a formulation or be it a chemical compound. And we got together with 7 companies in total, again, including also Covestro and Evonik for a good half day or 3/4 of a day, and started digging into that topic a little bit. So how do we approach it in the companies? What is our, I would say, approach to this? What is the approach to make or buy? What are typical pitfalls? What works well? What doesn't work so well? And again, as Nils said before, Of course, only within what is legally allowed, right? So we, of course, are always within the compliance guidelines and rules there. It was really more technical discussion that you might also have at a conference if it would have been focused enough. And even there, with this focused topic and the 6 or 7 hours that we had, we again found that this is by far not enough. There were so many topics coming up. So what we're now doing is actually having follow-up workshops on even more sub-granular topics, right? Because even materials discovery is not a one-size-fits-all. Do you have big data? Do you have smaller data sets? Are you looking for a compound or a formulation or a chemical molecule? What is it that you really want to do? It really branches out very quickly in terms of the different approaches that you're going to need. So yeah, that's what we started doing, and it's interesting to see because everybody brings something else to the table, right? You bring something for the other ones to learn from, and then you yourself learn from 2 or 3 others. So it's been an interesting journey so far.
Great. Thank you so much. 2 very good examples of cooperation and why it is so important to advance together in artificial intelligence. And we have some great questions from our viewers outside there. So I would love to go to the next questions coming from Zorlu, which is also a little bit related. So this could be something which could be jointly solved. So is the chemical industry looking at a cloud-based AI, which could help drive open big data solutions in form of global standards to provide solutions and experiences to users similar to an AI super app? Would that be something to advance jointly or not?
I mean, the idea is obviously great because with artificial intelligence, there are basically no boundaries to ideate what could potentially be possible. Yes, as we said a couple of times, our companies are still competitors in the market. So we have to look very, very carefully and also with legal guidance on what level of detail we are allowed to collaborate and we want to collaborate. Now, if there's a specific example on setting global standards, what I can imagine, especially because we talked about plant safety earlier, when it is really about our joint interest to protect the environment, to protect our employees, to protect their families, if one company in the chemical space has a great solution that lowers occupational hazard based as an AI solution, then turn this into a standard, I see that as a big advantage for not only the companies, but for everyone. So this is something I can imagine. Whether we will really have a joint formulation prediction engine that everybody uses, we would have to check with the lawyers whether that is actually legally possible.
Might I add something to that, Peter?
Yeah, of course. Of course.
It's still a fairly, I would say, new industry or fairly nascent industry. That means standardization is really just coming up as in any technological development. So if you look at other areas in the chemical industry for standardization or process industries like DXP, these things are happening. And I think at some point, certainly we'll see that happening too. That's kind of the standardization side. For the big data side, putting data together, I maybe even would go a little bit further, Nils. I do think that it will come also for process data or maybe even material data if the framework is correct, right? So if you're looking at frameworks like the made by the International Data Spaces Association or Gaia-X, which is now coming in Europe, they specifically are looking at how can we share data between players in an industry in a safe way, right? In a maybe even remunerated way where you can monetize that data, but you can jointly learn. And it's even possible to have data from different companies and anonymize them to a certain extent, that you can still use it as training data for a bigger system, yeah, even though that the single data packages cannot be read individually anymore. So there's certainly things that will happen, but again, it's a young industry. It's really just gaining ground as we speak.
Hmm.
And maybe to add one last point to that, if I may. there are many nascent fields out there in addition to artificial intelligence that will allow us to do just that. Homomorphic encryption, for example, something very near and dear to my heart as well, that allows us to train models on fully encrypted data, is really at the edge of cryptographical research currently. It still does not perform very, very well. It still does not perform fast enough to do this large scale. But in the future, we can envision that and we can use that, meaning we can fully encrypt all the data that we exchange, yet still train, as you phrased it earlier, a global AI based on that without giving away any individual data and any IP, but both being able to reap in the rewards of such a jointly trained AI. But this is really now cutting edge, maybe not in 2020.
Yeah, it's sci-fi to call it a bit, but not really. So, but there's another very good question by Bruno. It's related to circular economy, and this is not only touching Covestro, of course, this is touching the overall chemical industry. So how can AI help the chemical industry to achieve circular economy? Are there certain use cases, maybe short ones, because we have really a lot of questions here, so would be great to take that briefly.
I mean, on the overarching topic, there is an excellent article in Nature published at the beginning of the year that researched how artificial intelligence influences the UN SDGs. Short answer, it positively impacts many more UN SDGs than AI negatively impacts them. So that is good. And when we come from sustainability to circularity, a big question obviously is, well, if we do not get virgin material back, how can we differentiate the different materials, the different material grades, how to then break them up most effectively and efficiently? Here is where artificial intelligence can really help to identify which materials we actually do get back, and then also propose solution on how to best tear them apart and build new polymers out of that again.
Okay. Yves, something to add to that?
Agreed. I mean, it's the same for Evonik, basically. We're looking, of course, at the same KPIs, have the same goals. Circular economy of plastics is certainly a good keyword there. No, agree to everything.
Good. There's a good cultural question in between by Wolfgang. So how do you share your insights gained with your advanced methods with non-AI experts?
Yeah, that's maybe I'll take that one, Nils. So that's a very good question, because you won't get any traction in the company if you cannot make it accessible, right? It's not going to help you if you have 50 good data scientists, but they are not able to translate it for the common user, and maybe even instill fears, not have technology acceptance, and so forth. So this is really, you cannot just deploy the technology. You really have to look at the overall picture. You have to upskill your people. You have to demystify the topic. You have to break it down in a way that they can, of course, understand it, but also give them a chance to actually learn and to get on the boat to a certain extent, right? Not everybody has to be a data scientist. I'm not a data scientist, for example, but hopefully I'm able to somewhat intelligently talk about some of these topics, right? I understand the gist of it and I understand the potential value of it. And that's enough for me, right? I'm not going to be the one that's going to be implementing them in detail. So don't see this as an isolated technology topic. I'm an engineer, so for me, typically I always say, if you bring me a cool, new, nifty technology, I'm going to be all for it, right? But that's not true for everybody. And we have many, many different characters and personas in the company. So make a big effort to really take the whole company with you. And that takes time. This is, again, to a certain extent, culture. It's not done in half a year. But also AI is not done. AI will develop further. So don't forget your people.
And especially on that demystifying topic, what we are doing and what we have found to be working very well is train the models jointly with our colleagues. Because seeing how stupid from a human perspective. A model is going to be, in the first couple of iterations, helps them to take away this fear of the super intelligent being. No, we're building machine learning models here, and if you see how they evolve, you might not understand the nitty-gritty details of every step that is being performed, but you kind of get an intuition of how clever and how smart they are, or how much of a tool they really are. So collaboration also internally is the way to go here.
And this is terminology, right? So we talk about narrow AI here. They really do only one specific task. Yeah.
Yes.
So and people often underestimate that. That's certainly true. Yeah.
Right. Next question comes from Igor. So how accurate are your machine learning models in comparison with routine handmade selections? A little bit referring to the question before, clash of cultures.
I mean, there is no, from my point of view or from my experience, there is no general answer to that. Usually what we do is we look at challenges that have been attacked with various methods without yielding too positive results. We always look at the baseline of the current model as a baseline for how well a machine learning model would have to perform in order to bring an added benefit. Once we are there, we then determine, is it really worth it to make the switch or not? In many cases, the results are quite clear. Quite clear meaning either no, our models are not able to extract enough signal from the data that we have at hand, and hence it does not make sense to let a machine learning model do this specific task. On the other hand, if the model building is successful, usually we have differences of 65% accuracy as a baseline to 85 or 90% accuracy of the model. And then obviously it makes sense to make the switch to a machine learning driven solution.
Mm-hmm. Okay, something to add, Yves? If not, we go on.
It's really a difficult topic because you cannot answer that specifically. There's many different usages. So
definitely. Another one, how can we learn to apply AI in polymer synthesis? Is asking Parveen. So would there be a short answer to this long, complicated question?
I don't have a short answer. No, I don't know if Nils has a short answer, but
I do. Collaborate and just do it. It really is collaboration. If you have expertise in polymer synthesis, call up your colleagues who have experience and have the required expertise in machine learning, and just do it jointly. I always learned from every collaboration that I've had throughout my life and my career, and the same applies here. So simple answer, Nike, just do it.
Another question. So what about patent issues? Since AI is totally based on data, I feel there is a risk of data leaks or system hacks. We had this in regard to safety just before here in the discussion. So this is a question by Yasir. Thank you.
Yeah, so in many cases, the AI systems that we deploy are in-house, right? So they really work only internally. So we don't really have that danger that, for example, if you have something on Google, or if you have a customer-facing system, that it can be breached fairly easily, that you lose things there. In terms of patenting, again, there's two ways of interpreting this question. In terms of patenting, there's actually a whole long discussion if also an AI actually can be owning, for example, a patent if it invents something new. I know that's not the question here, but I think it's a very interesting discussion. So if, for example, SciTAI, right, would invent a new material, who would be the inventor of that? And in that case, would it be the AI, SciTAI, or would it be actually the person operating the system? yeah, that maybe as a fun aside.
Wonderful. Yeah, next one, a long one, referring to the point of saving money from not doing experiments due to AI. What is the time frame for the ROI? As our controlling friends always want the number before releasing the budget, asks Ulf. Well,
that is a topic that has been widely discussed at Covestro, and what helped us to come together in the end was the understanding that I shared before. Machine learning and artificial intelligence still follows the scientific principle, meaning we have to perform an experiment to then know and observe what the outcome is. We are not able to predict the outcome without doing the experiment. So what this means for us is we have accepted as Covestro that doing these experiments carries an inherent business risk. And as long as some of the experiments pay off, we're good with that. And this is really just accepting that whatever we do in AI, we cannot calculate hard business cases because we do not know beforehand whether it is actually possible to do that based on the data that we have. And in this regard, AI differs dramatically from software solutions, where if you buy a commercial off-the-shelf software package, you know what it's going to do. You probably can estimate how long it takes to implement it, how long it takes to train people to do it, and you know the tasks it will be performing. With AI, without the experiment, you don't know whether it's possible at all.
And there's maybe actually another payoff there. So depends on where you are in the adoption cycle of AI in your company. So if you haven't done a lot, then honestly, and I know that many companies see it differently, but my approach is start doing something. Just start doing it, because you will learn the right questions. You will educate your own people on what is possible, what is not possible, what the value is. If you start, or if you try to make a business case for the first 1, 2, 3, 4 POCs, proof of concepts or pilots on AI in your company, you're never going to get anywhere. You have to learn first by doing. At some point, though, of course, you're going to need business cases, but specifically in the beginning of adoption, it's okay to just learn. Yeah.
So let's come to our last 2 questions for today. So there is one last question coming. No, it's not the last one, it's the one before. So what are the best possibilities for academic researchers to approach industry for corporations regarding AI research? Asks Julian.
LinkedIn, no, I mean, it's contact, right? In the end, that's certainly one possibility. I mean, there's also things like, let me see, Chemcologne is an example. Chemcologne is an verein. I don't even know what the English word is there.
Corporation or organization, yeah.
Organization. And they organize, for example, certain, I would call it hackathons, right? Where then you bring corporates together with academia and startups. That could be a potential option. I mean, hackathons in general are open. If you have papers, of course, that will get us, notified. We hire people from academia, right? So often people bring that network with them and then say, hey, my professor has done something cool. Why don't you talk with him? So in the end, obviously, it's always networking, right? And you can create that network yourself, be it through LinkedIn or through people that already have gone through industry.
Right. So this is nothing to add. Yeah.
Okay.
Wonderful. So the last question for today. So the third industrial revolution was all about factory automation. Will the fourth AI-driven revolution be all about knowledge work automation? How do you see the development of organization and cooperation model between humans and machines? Asks Michael. A complicated question for the end.
Yet a very, very good and a very relevant one. Yves-Gorat mentioned it earlier. We are currently in a phase where we talk about narrow AI, meaning an artificial intelligence that performs very, very specific tasks, sometimes very well. I am a big proponent of the concept AI, not meaning so much artificial intelligence, but augmented intelligence. Because in the end, and this is simply where we are globally in the adoption cycle, if we leverage what this technology has to offer in upgrading the potential of our colleagues, of our families, of our friends, this is what will lead to a harmonious coexistence between the two. And this is me closing with something borderline philosophical. I am of the conviction that artificial intelligence necessitates us to rethink what actually defines us being human. And in that regard, I see it as a great benefit to us as a company. I see it as a great benefit to us as a society and to us individually. And with that, maybe Yves-Gorat has also a viewpoint on that.
No, it was so beautiful. Don't really want to, get in the way of that. Augmentation is really a good phrase. It takes away many tedious jobs that honestly we don't want to do anyway. And it gives us time to focus on what we're good at: judgment, creativity, thinking about these kind of, how to bring things forward. But it takes away all the laborious, filling out Excel files and scanning documents and all that kind of stuff. So I think it's actually valuable. Yeah, it really augments us, as you said.
Very good last words to close this hour of super interesting conversation, interviews, presentation of new topics on AI and chemical industry. So thank you so much, Yves and Nils, for your time today and to share your knowledge with our viewers outside there. Very much appreciated. Thank you very much. Super interesting. And of course, there will be many more questions from you outside there, we are pretty sure. So you could always send us the questions on our channels and we are happy to answer them and give them to our experts, Yves and Nils. So please let us know and send us your questions. So you followed volume number 21 of Covestro Home Office Talks today, live as always. And please tune into our next live talk in 2021, next year. And have a great Christmas time with your beloved ones. Stay safe and stay healthy and have a great week. Bye-bye. Thank you.